Okay, consider the arc length. It looks like a pretty complicated problem, by the way. What I'm going to do, though, is do the derivative first, so dy dx. So I see the 16th minus 1, it's 1/16. It's chain rule now, so it's going to be, the derivative of log is going to be 1 over its argument. Times the derivative of its argument, which is going to be minus sine of 16x, times the derivative of the inside, which is 16. Again, it's in your interest to simplify these guys over here. This will be minus, the 16 cancels, and you're left off with what? Sine over cosine, which can be tangent. All right, what I'm going to do now, square it. And you're going to get tangent squared, sorry about that, tangent squared of 16x. All right, so I think I can write the integration down now. It doesn't look that bad. It's going to be 0 to pi over 48. It's going to be a root of 1 plus the tangent squared of 16x, and then dx. I noted an identity for this, and it's important that I write that down because it looks like it might make it a substantially easier problem for me. And 1 plus tangent squared is secant squared. What's nice about the secant squared in the interval between 0 and pi over 48 is it's going to be a positive. So I know this is going to be secant of what? 16x dx. All right? Now this is the part where a lot of students say, I know I've seen this before, I just can't remember it. And I'm not opposed to telling you what it is. So what I do is say, someone said to me, if this is an exam question, what's the antiderivative of secant? Oh, I would probably write on the board, the antiderivative of secant of u du is going to be ln, absolute value, secant, and we derived this in class, by the way. Certainly be willing to tell you that, right? Plus c, by the way. So I would tell you that. Let me erase that. I'd probably write it on the board if someone asked me for it. I wouldn't tell you it's useful, though. If someone said, well, what's the answer of secant x? I probably would write it on the board, by the way, even if it wasn't useful to you. Right? Like a lot of times people ask questions, and I need to answer them, but they're just not useful on exams. All right? It would be useful here, though. Right? Before I do this, though, I want to make a u substitution. And the u substitution for me is going to be 16x. And du is going to be 16 dx. Write this over here. So if x is 0, 16 times 0 is 0. And if x is pi over 48 times 16, that'd be pi over 3. Relatively simple. Secant of u. And then dx is going to be what? It's going to be, let's see, du over 16. So I put the 1/16 out here, du. Let's go to town in that. What do you get? 1/16 natural log, absolute value, secant of u plus the tangent of u. We're going to evaluate this from 0 to pi over 3. And let's try it. 1/16. And just to remind you, pi over 3 is 60 degrees. I'll put a little triangle over here to help you out with it. That's pi over 3. Root 3, 2, and a 1. All right? So it's going to be ln, absolute value. The secant of that pi over 3 would be, well, the cosine would be 1/2, so it's going to be 2. And then the tangent, let's write that down. Right? The tangent of that would be just root 3. Minus 1/16. And then it's going to be the natural log, absolute value. It's a 16th, by the way. Let's see, the secant of, we're at 0. Yeah, secant of 0 is going to be 1. And the tan of 0 is just 0. What's nice about this, the log of 1 is just 0, so this disappears. So I got my answer. What's my answer going to be? The natural log. I want to point out that 2 plus root 3 is a positive number, so the absolute value, I can remove that now, over 16. Put a little box in this. Look at the answer key. I'm not looking at the work in the answer key, by the way, but we're looking at this, and we're getting the same answer. I do want to encourage you to look at the work, though. A lot of times people say, well, why don't you look at your work? I did. I mean, I did this problem, I can't remember, but I'm going to say years ago, and now I'm making a video for it. And, I'm aiming for the answer, what I'm aiming for. Right? You can look at the work. It should be relatively the same, by the way. Thank you.